Hello everyone, I am Rishita Agrawal, EPH third year student. Today I am here to demonstrate the experiment study of LDR characteristics. LDR stands for light dependent resistors. It works on the principle of photoconductivity as its resistance changes with the intensity of light falling on it. This is the apparatus for the LDR characteristics experiment. It consists of three main parts. First is the supply voltage. It comes with a knob. As we rotate the knob, we can increase or decrease the supply voltage. Second are the voltmeter and the ammeter. The voltmeter shows the reading of the supply voltage, and the ammeter shows the reading of the output current when we show light on the LDR. The third part is the LDR, which is mounted on the surface of this apparatus. It consists of a pair of metal film contacts which are separated by a zigzag track that is made up of cadmium sulfide. Cadmium sulfide is a semiconductor. So when light is projected on this LDR, the electrons in the valence band of the semiconductor take energy from the photons and get excited to the conduction band. As a result, free charge carriers are introduced in the semiconductor, which allows charge to flow through it. As a result, conductivity of the semiconductor increases and resistance decreases. So, as we increase the intensity of light falling on the LDR, the resistance of LDR decreases and the output current increases. Now I'll be performing two experiments using the LDR characteristics apparatus. In the first experiment, I'll be studying the variation of resistance of LDR with the intensity of the light source. For this experiment, I have kept the supply voltage fixed at 1.50 volts. As we know, the intensity is inversely proportional to the square of distance. So, as we increase the distance between the light source and LDR, the intensity of light decreases. As a result, resistance increases. As you can see that in the absence of light source, the reading of the ammeter is 0. Now I'll keep the light source at a distance of 25 centimeter from the LDR and note down the reading of ammeter as 0.01 milliampere. Now I'll reduce the distance between the light source and LDR to 20 centimeter and note down the reading of ammeter as 0.02. In the same manner, I'll keep on reducing the distance to 15 centimeter and note down the reading as 0.03. At 10 centimeter, 0.06, and at 5 centimeter as 0.13. Now I have recorded all the observations in the form of a table. The supply voltage was kept fixed at 1.5 volts, and as I varied the distance, the reading of the ammeter changed. Uh, for every reading, I have also calculated the resistance of LDR by using the formula resistance equals to voltage upon current. Using the table, I have plotted the curve between the resistance of LDR and the distance between the light source and LDR. As we can see from the graph, the relation between the resistance and the distance comes out to be approximately hyperbolic in nature. Uh, from this experiment, we can see the following results. As we increase the distance between the light source and the LDR, the intensity of light decreases because intensity is inversely proportional to the distance. The resistance of LDR increases as we increase the distance between the light source and the LDR. That is, resistance increases with decrease in intensity of light source. The nature of the resistance of LDR versus distance between LDR and light source plot is hyperbolic. Now Now for the second experiment, I'll be measuring the latency of the LDR characteristics apparatus. Latency refers to the time taken by the electrical device to respond to any changes in the input.
Now I'll note down the time the LDR takes to respond when the light is suddenly switched on. To come to a stable reading, the LDR took 1.04 seconds. Now I'll note down the time it takes to come back to its original resistance when the light is turned off. The time taken by LDR was 0.87 seconds. So we can see that the LDR can take up to 1 second or more to respond to any sudden changes in the light intensity. Conclusion. From the experiments, we can conclude that the relation between the resistance of LDR and distance between LDR and light source is hyperbolic in nature. As the distance is increased, light intensity decreases and the resistance of LDR increases. Because of its latency, LDRs are not suitable for circuits where the light intensity changes very rapidly. However, when the light intensity changes takes place over a period of time, LDRs is quite useful. Thank you.